And hello Cinemeric Nation, and welcome to Simply Cinemeric Live, the 2025 Christmas special. I'm your host, Chris Pollock, and today we're going to have a little fun. Certainly this is the event of all the events we do all year long that I look forward to the most. There's something to be said for getting a chance to let your hair down a little bit, my golden locks, and play around with something like a Christmas ornament. And you know, we'll get a chance to leverage some interesting technology, so you don't totally get off. You will learn a little something in the process, but have some fun as well. So this year we decided to machine a little star. It's actually a cylinder, so we have curved surfaces on the outside and the inside. Looks nice hanging on the tree. And what we're doing is I'm actually letting this build on a series of sessions or events that we've already done leading up to this point. So if you happen to follow us already, you may have seen the webinar we did on dynamic fixture offsets. We did that a couple months back. It's certainly posted on the Mr. CNC channel, so you can check it out there if you didn't see it. And then about a month ago, building on that webinar, we did a segment. It was a YouTube Live, similar format to this, where we went in and we calibrated the fourth axis for dynamic fixture offsets, or Cycle800 as we like to talk about it in the Cinemeric world. And now we're going to use that to actually machine our ornament. Now I will say the cycle time on this part is quite long. I would actually challenge those that are on the event to maybe take a guess at how long it would have taken to machine this. I will tell you, spoiler alert, it's longer than we're going to be here for today, certainly longer than a half an hour. But it'd be fun for you guys to maybe enter into the chat and take a guess. And at the end, maybe we'll get a chance to take a look at some of the guest times and see who got it. All right, but with that, this part we were able to actually use and collaborate with Kurt Workholding this year. And this is a really cool application to take advantage of what we would refer to as a self-centering vise. So in this event, we're going to go through the entire setup of how to get that job running. We will start cutting the part, and then we're going to take a look at the programming side, looking at our digital twin, my virtual machine. We'll look at the CAM solution, how I designed it inside of CAD. We're going to go through the kind of whole end-to-end process. Now, with the Kurt self-centering vise, this is the PFW 440, so it's a 4-inch wide jaw set. Has a max capacity just under 5 inches. It depends on which jaw you get. I decided to go with the serrated jaw for this job so I could minimize the amount of material I was clamping on, but still get some really good clamping force. Now this, typically we think of this as a 5-axis vise, but really works quite well for a 4-axis application, and especially if you leverage their quick change plate. So this plate is bolted right onto my face plate, and now I can rapidly remove the vise, maybe drop a standard vise, a 3-axis vise on my table, take that off, put it back on, and I don't really care where this is in relation to the center of my 4th axis, because I'm going to use Cycle800 to adjust to wherever my part ends up falling. So let's go through the actual process of setting up the job. We'll get it running, and then we'll talk about the programming. Now, first thing I want to do is I'm going to go in and actually clear any of my existing work offsets. I like to do this out of habit, so this way I don't inadvertently forget any offsets. So I am using G54, and if I go into the details, you'll see all of the offsets we have currently set up. If I hit this clear work offset button, everything gets zeroed out. So we're going to set up the whole entire job from scratch. Now from there, I do like to make sure my A is positioned at 0 as I start, and then we'll do some alignments. Now, the way I did set up this vise, I could certainly drop her in this orientation, nice and easy, right? and I wouldn't have much alignment to do it all. But I wanted to kind of show you a worst case scenario. So what if my vise was sitting and I couldn't get to the datum surface that I would normally do to do my align edge? So we're just going to drop this on, lock in the vise. All right. I'm going to grab a little rough stock here. Now, one of the things you do want to watch out for when you start to use a work holding application like this is a lot of times I like to just, saw cut and go, but my saw cut surface is not really that square. So when I grab it in the vise, it could kick it out of square because it's going to obviously datum on this bottom surface. And if I don't have enough material, I may not clean up all the way around, especially on my faces. So I do want to kind of watch that. So I did pre-machine this back edge here, just to make sure that when I grab it, it's flat. Now, I'm not too worried about where it's sitting in the vise, but what I do want to do is I can, for Cycle800, I can shift this thing anywhere I want. However, as you're going to see when we get into the programming, there's a lot of areas that I had to watch for avoidance. So if I shift the part significantly out of where I modeled it in my CAM system, then my avoidance strategies may not be right. So I want to eyeball it. Obviously, it doesn't have to be perfect. I don't have to indicate any of this. Cycle800 is going to kind of handle all that. Okay, so we're in. Now, the first case, obviously, we're going to start to probe, and I want to always do my align edge initially. So let's grab a probe. Okay. And again, keeping in mind, if I was to swivel to 0, this part is standing straight up and down. Now, I don't have enough surface area to align to this, and this is actually the surface that I want to be surface normal to my spindle. So there's two ways I can handle this. One, I could just manually jog it kind of close, and then inside of my align edge cycle, I could use this special angle feature to compensate where I am from 0. You can do that. I find it kind of confuses users quite a bit with the special angle. So what I like to do is I like to kind of get my 4th axis roughly in position, right? So I see I could probably have about a 90-degree offset in here and then coming down and do my align edge. So what I'll do is I'll put a rough offset, and this could either be in the A or in the coordinate rotation about X, either one. I'm just going to do it in the A for now. And now if I drive to, again, still 0, 0, 0, my 0 is going to take into account that A offset. And now if I come down to measure this surface, I don't have to put any special angle, and it will calculate the plane properly. Now, one of the things I like to do when I start to work on a scenario like this is I like to kind of stay as close to my work holding as I can. This way I'm not taking into account any deviation where this rough material may be out of square. I want to get as close to my work holding as possible. In our align edge, what we're going to do now is I'm going to utilize writing to my work coordinate. I do want to take my measurements in the Z, and my reference angle, or the angle that, or the axis that I will be positioning back and forth, will stay Y. And then where do I want to write this offset to? Now, it's important at this stage, I want to write it to wherever I put that initial rough offset. You don't want to ever intermix coordinate rotations with direct axis offsets. So if I put it in the A, keep writing to the A. If I put it in the coordinate rotation about X, then write it there. I don't need a special angle, so now cycle start, and we're going to get our first measurement point. And now we'll come over, spread out your measurements as far as you can. That's going to make it the most accurate. So come down, measure off that surface. And now as we do the set work coordinate, you can see it actually calculated 89.373. So when I mounted this master plate, I didn't indicate this in. I kind of eyeballed it, so I got it better than a degree. But now we are perfect. Now here I get a little pop-up screen. This would be the same as if I went to the swivel cycle, but it just gives me a chance to get the probe up out of the way a little bit. I use the incremental strategy just to move back, and now I'm aligned. I have to do this first before I do any other measurements. Now the next two axes I'm going to measure is my X and my Y. So from the X, what I did, so I was making sure that I'm working from a fixed datum all the time. I actually measured off of this surface. Now I set the 0 on my part, you'll see it later when we get into it, out here in the front, but I know from when I designed it, the distance from the front of this part to that jaw is 4 inches. So I'm just going to do a basic edge measure in X, and I'm going to tell it when I hit that jaw, I want to be sitting at positive 4 inches. And that's going to position my 0 appropriately. So if I came back, you'd see a little bit of plus stock on here. This could actually go all the way to 0. It's okay because I shifted the ornament in slightly. If you look at how I kind of positioned it, I did position it at a little bit of an angle. So our little, knob here, point where I'm going to hang it off of, was actually utilizing the material in the corners. Just trying to, maximize my material. So now my X is set. To set my Y, I'm going to utilize our 2-point measuring, which will calculate the center of my Y. And in this case, I now just have to come in. Again, I like to try to keep everything as close to the work holding as I can. As long as I have enough rough stock, it would still all clean up anyway, but just to be on the safe side. Now we'll come in, find that point. And all the while I'm doing this while Cycle800 is active, and that's important. I want to have Cycle800 active throughout the process. That's why I like to drive it to 0 with Cycle800 and then start all of my measurements now with it there. Okay, I want to set the work coordinate. It just found the 0, so if I move back somewhere roughly the center, you'll see now we're at 0. And now the Z comes in, and the Z is an interesting one because I got a couple challenges when I go to do Z. I could come down and do a single edge kick right on this surface, but now I'd have to take into account the rough stock and then half that, and I have some potential error there. What I could do, if I wanted to get it a little bit more accurate, is I could put in like a 1, 2, 3 block or some kind of a standard first to find the center line of this jaw set, because that's really what I'm trying to find is the center line of the vise. The only thing I don't love about this process is as long as my 1, 2, 3 block's pretty close to my stock size, I'm at the same point in the screw. But let's say I was going to move out to a 3-inch block, working from that, what is guaranteeing that these jaws are really centered in the same spot? Nothing. It doesn't really matter when they machine this to make it super accurate, right? So what I like to do, and if you're on a cinemeric, it makes it pretty easy, is I actually use the dynamic fixture offset in my favor here. And what I can do is I can actually do a measurement in Y to find Z. Now you're going to say measurement in Y to find Z. How do you do that? Well, it's actually quite easy. I can come in and I can swivel my part with the swivel cycle, with the Cycle800. And now the system's tracking. Now we're going to come in and do the exact same measurement we did before. Literally, we're going to take the measurements in Y, but since it knows the part has been spun, what it calculates in Y will get applied to the Z offset. So before I run it, if we look at our work offset, you'll notice the Z field right here is 0. There's no value inside of that offset. I come back, I'm going to take a measurement in Y in the plus direction, just like we did before. All right. Come to the other side. Now we'll do the set work coordinate. And if we look at our offset, we saw a value go into Y really quick, but if you see now it calculated the -17. So that tracking of the dynamic fixture offset I can use to my advantage even in the setup. So now I can kind of have full freedom of when I'm doing my setup. So at this point, we have now established our 0. So we can start the part running, and then we can dissect a little bit how I program the whole thing. All right, we get a little coolant on her. Once we start cutting, we'll go over to our program. It's in the Christmas 25. Now I'm going to give you guys, and I'll mention this a few times during the event, I'm going to give you guys all these files so you can download them and kind of look at them and play with them a little bit. I am using my main program strategy. We're going to talk about this quite a bit when we get to the PC, but just want to make sure everything looks good. I don't need any op stop. We're going to let her rip. Okay. So first thing I'm going to do is I'm going to come in and do a little bit of facing just to clean up these two surfaces. Just want to make sure everything looks good before we change our direction and start to look at and we're going to talk about this operation first. You can see we're getting pretty close to the jaw set there. You're going to get a chance to kind of, we're going to talk about that a little bit. But everything looks good, so we can let her run. And now let's start to talk about how I programmed it, how I methodized this part. So I did it in a couple different steps. You know, when I get a chance to kind of play with these types of jobs, it's a great opportunity for me to kind of freshen up my skills. I like to use different pieces of software. You know, I unfortunately don't get a chance to methodize parts all day long, so sometimes my my skills will get a little rusty on me. So wherever I can, I like to just get a chance to use some different pieces of software. So first thing I did was I designed it all inside of NX. You know, I like to kind of lean on NX certainly as my preferred choice when I get into doing design work. I do a lot of CAM-based programming out of it as well. In this case, I decided to do the toolpath from Mastercam, again, to just get a chance to play with some of the newer versions of Mastercam. But it was first modeled completely in NX. You see there's a curvature to the outside and the inside. Obviously, I built it from a complete sphere and then kind of cut off the top, cut off the bottom, and that was kind of where I started from when I started building this part. And I cleared out the middle, did a revolve on the inside radius, and moved on. Now when I got to the cam side, there I decided to go into Mastercam and work from the Mastercam side for the programming. So I imported the model from NX and then started working here. And I like to use both my CAM solution in conjunction with my digital twin to start validating and proving out my job. So we're going to kind of take a look at both. We'll start inside of my virtual machine, and then we can maybe jump back to Mastercam where it seems fit. So if I start to run the program, the first thing I'm using, and I want to kind of show you, is I really love a main program sub-program strategy. So if you look at my program folder that I'm working from, right here in my NC, now I do a couple things. I certainly like to maybe work from an internal folder, but then I'll also use a shared folder that I can post to from Mastercam or whatever NX, whatever I'm using. This shared folder, I can then quickly grab my toolpath and start to run it in my virtual machine. It's that same share folder that exists over on my real machine. So now I can be working from a common source all the time. That really kind of streamlines the whole process. Now the other thing you'll notice is I have this main program and then I have all of these subs. Op1, Op2, all the way up to Op17, and then I have a main program. Now the main program, the way I wrote it, and you're gonna get this if you download the material. So what'll happen is at the end of the event, I'm gonna post a link in the description, it'll stay up there, that will give you access to my Google Drive, and you can pull down, I'm gonna give you the NX part file for the model. We're going to give you the Mastercam file. If you happen to use Mastercam, you can look at the toolpath. And I'm going to give you all the part programs if you want to play around and dissect them a little bit. Now, when I built this main program routine, I wanted to make it as flexible as possible. I don't want to have to, I kind of got tired of having to rewrite my main program every time with, you know, oh, I have 6 calls this job, 8 calls the next job. So I'm able to do this entire thing with only 1 sub call. And I do this by adopting a naming convention, and I keep it consistent. So the naming convention is always going to start with OP followed by a number. And it's this R1 variable that I'm automatically indexing through this routine, and that's how it knows to jump to a new program every time. Now, if you decide to have a little bit more of a name, in this case I called it Ornament Star. You don't have to have any of that, but if you have a name after your OP and your indexing number, then you want to make sure that that name is also right here in the definition of this string variable. So about that, the only thing you'll have to modify if you use this for your own jobs is basically this underscore through just before the .mpf. You want to leave the .mpf inside those quotes, and then you can either replace this portion of the name right through here, or you can delete it, and then your names could be Op1, Op2, Op3, and so on and so forth. Now from there, the only other thing you have to do then is go to this top definition here and tell it how many ops you had. So in my case, I had 17, so I had changed this number to 17. Now to get this a little bit more automated, when I went to posting, inside of Mastercam, this is a feature that I love, I can actually go into the operation and define what the output name of this file is going to be. But all the operations have to be the same file name. So in this case, I used op1 underscore ornament star for my and my second. So if you look here, you'll see the second one's the same name. Toolpath. So I'm just jumping over the in-process stock model. My next toolpath, if I take a look at it, now I'm using op2. And the beauty of this is if I have all the ops selected and I hit post, it will now output all of those individual programs automatically for me. So I don't have to think about it anymore. It really makes it kind of slick. So now, on the programming side, if you look at the first op, here I allowed 2 different operations really to come out because I had no reason I would maybe ever really care about starting from the second one. But as my toolpaths get bigger, like op3, or op2 in this case, as my toolpaths get larger, we can open this up. Open that. You can see it's a big toolpath, right? Now the system's going to track wherever I was in the program and know what operation I was in at the time if I abort mid-program or if I want to start mid-program. So you're going to get to see that a little bit more. But in this case, let's start the main. We're going to start running it. You're going to see basically what we're seeing behind me as she cruises around. And now, as I start to get into this type of methodology, right, I start to see one of the areas where I have to kind of watch out. You know, if I was doing this in a standard 3-axis application, I can keep things as short as possible. I can stub everything up, because usually I don't really have too much in my way, especially in a Z vertical orientation. But when you go to this multi-sided machining off a 4th axis, now you can see my clearances are pretty critical. So you are going to have to start to use extended reach tools wherever necessary, whether it be in the cutter or maybe in the holder. You're definitely going to want to leverage some kind of collision avoidance from the cam side if you can, and certainly validate it here and protect my machine, because this is where I really start to see the real machine. So you can see I can just got enough room, and I'm not just worried about the holder. And this is what I don't always know from the cam side. I want to really watch the machine elements too. So in this case is perfect use case for my virtual machine, because I know this was built as a one-to-one to my real machine. So now she starts running, we're facing it off, and then the system will automatically return to my main. It's going to index that R number, and that's how it knows to jump to the next operation. So if you see here, it's going to go through in a second, and we're going to get into the roughing, which is, yep, what she's doing right now. And we're on the second side of the roughing, I see. So there's my last pass on the face. We'll come down with the 3/8 tool. Now this one, I was certainly far enough away, and I used a long enough holder here. I wasn't too worried about anything. I could kind of go, rip it and go. As I start to move through, now we can start to look at different processes. Now in this case, I did use a little dynamic milling toolpath to clear all this. If you watch it through, or if we take a look at it here, I do what's strategy. So I can come in and it'll clear an entire minimize the limit. So I wanted to jump right into finishing after this was all roughed out. You know, if I was going to really try to get this thing perfect, I probably would semi-finish all these surfaces with my ball end mill. I used a 4mm ball for this, and then come back and do a final. But all in all, I would say the surface finish came out quite well, considering I went right into a finish operation next. Now, to kind of jump into the next process, I used a technique within my... I create a save in process workpiece. And what that allows me to do is I can create stages or steps as I go throughout my operations, and I don't always have to start from the beginning. So here we're just going to jog her up, out of the way. I can come into my setup, remove my current setup, and now you see this Op4 setup with the magic of TV. We have now roughed out the part. There we see it all roughed out, top and bottom, and now we're going to go into the finishing op. So I can utilize my little R variable now to jump through to a new operation. So by changing that to 4, it's going to jump, it's even going to warn me, jump to operation 4, and now we're going to start finishing it. And so what I did was I wanted to keep this thing as stable as possible. I'm going to get rid of the guard so we can see a little bit more here. So I decided to do all of my ID finishing before I rough out any of my OD. You know, a lot of cases I would rough everything out, let my part kind of move where it's going to, and then do all my finishing. But in this case, I didn't want to compromise my rigidity. I was more worried about my surface quality than I am about maybe my geometrical integrity, right? So in this case, we come down through, I rough profile all of it. So if you look from an operational standpoint, there's my second rough. Here I ball mill down, and I did a consistent spiral all the way down. Zipping all the way down through. And then we jump down to the lower portion. Do the same thing here. And then I start to spiral out the star. And I like to, whenever I can, try to keep a consistent toolpath strategy throughout. So even in the star portion, you'll see that I work from the middle and I spiral all the way out, giving me a nice uniform toolpath, which ends up giving me a nice consistent surface finish on that star. This was a 4mm tool. I am quite happy with the surface finish. I think if I really was going to get anal on this thing, I probably could come back with a 2mm and really make her shine. But for this little job, I think it came out great. Okay, so once I finish all those surfaces, now we can out of the way. Boom, boom, boom. We're going to jump to our next operation. So that was 4, now we're coming to 8. And in 8, we've now finished machined all of my surfaces. So if you take a look, you'll see the stars now roughed out. The inside radius is all finished, machined out. So now as we continue through, and for those of you on, I see we already got, Timo's got a guess in, so try to guess that cycle time. I'm curious to see how many people get it close. So in this case, we'll start from operation 8, and now we'll do a little bit of light engraving. Now initially when I had designed the part, I did design it, if you look at it from the NX perspective, with embossed text. But just to keep things a little simpler, I ended up doing my engraving inside of Mastercam as single line text, just to engrave the 2025 and the Merry Christmas, certainly reducing my cycle time and the need for a lot of small tools. Now once we've done all of our engraving, then we're going to come in and we're going to start roughing out the outside. So here is where I as well leveraged an adaptive milling strategy. And now I really have to start to watch myself when it comes to collision protection or collision avoidance, because I can get quite close to those jaws. So we'll jump into the tool path and I'll show you a little bit of how I did that. All right, so there you'll start to see we're doing a little adaptive. There's your little repositioning, trying to climb mill, obviously wherever I can. And if you watch, now we're going to start to get awfully close with this solid end mill holder to that jaw set. So to keep me from getting anywhere near it, I did leverage collision avoidance inside of manufacturing the toolpath or programming the toolpath. So if we come over here, there's our ball end mill, there's our engraving, yep. So this is our dynamic roughing, all right. And if I come into the parameter set, now what I can do is I do have to go through the steps in my CAM system of defining the entire holder, and it's got to be pretty accurate because it's going to make its decisions here. But when I define my geometry, I can utilize my work holding that I brought in to say, hey, I want you to stay away. I want you to stay away from those surfaces. In this case, I gave myself 50 thou clearance off of that wall. Additionally, you got an extra 50 thou, so really I ended up 100 thou clearance. So keep in mind, these will build on each other. I was able to use the avoidance piece to just kind of gate my toolpath to make sure that it doesn't try to do anything internal. That thing is done. So I said, hey, avoid that whole top surface, just stay on the outside. The other thing that you can do is you can also gate your toolpath by creating what we call a boundary chain. That's another great technique to keep the tool. Sometimes you'll see that these tool paths will go like way outside and try to roll around right through your vise. So if you kind of create a simple wireframe, and that's what you'll see here, if I turn on some of my levels, you can see I created this wireframe to say, hey, I never want you to go outside of that area. So I use that technique quite a bit to keep the tool contained where I want to contain it. That allowed me to start to rough out the entire part. So we'll jump back here. We can reset that. Now we go into the next stage. We'll import, we were on 8, we'll go to 11. So now, now the entire part has been roughed out. I did an upcut strategy as well here to get you know, to get this to start to get as close to the final shape as I could. Now I can't ball mill this yet, right? I need to go in and I need to do a little bit more clearance. So in this case, I did have to leverage a pretty long tool to start to clear out this material. Now, I wanted to give myself as much room as possible here. So as I come down through, oops. Oh, a little drilling. But in this case, you'll see now I'm coming through. Now, I'm not doing the final tabbing. So this part used a pretty cool technique where we did end up tabbing this, and that tab was only 20 thou thick when I was all said and done. So you can kind of see it vibrating here, right? That is not going to be generated just yet. This is giving me my clearance for my ball end mill so I could ball mill as much of this thing as I could. Now, I'm going to end up losing a little bit down here at the root. You know, if this was like a real manufactured part, I might figure out a secondary op to clean that up. For our ornament, I think it's pretty good. A little quick hit on the buffing wheel and you can make it look beautiful. So this will start to clear all of that material away, and what it's going to do is it's going to end up leaving this lower tab right here. And then I can start to go into my, a little more. There's my drill. There's where I clear out both sides. That's what we're working on now. And then I'm going to do the same type of ball milling technique, spiral all the way around. Now where I wanted to be careful, and I probably machined a little more material than I had to, but I knew I'd get some jumps over this post or this stem or this tab, and then she'd want to reposition in or out. So in a case like that, I wanted to give myself enough room that I could kind of get the tool in there. I think I was probably a little over conservative here. I think I could have gotten certainly a little closer, but you can see I don't have a ton of room. We're starting to get pretty close to that jaw set. I did minimize my lead in and lead out as much as I could here to kind of keep that safe. But then I ball milled that side, flipped her over, ball milled the back, and then the final operation was going in and doing our final tabbing. So in this case, we can get her up out of the way. I got a lot going on, slowing me down. Okay. So we'll remove and go to our final op 14. This is the state at which she'll be in when I finish the ball milling. And then I come in and do the tab. So if I want to see what the tabbing looks like, we can run that real quick. Now for the tabbing, I like to use a more traditional tricoidal style, not an adaptive toolpath. So this 16 is the start of my tabbing. And you kind of got to go for it. So you don't want to do like multiple steps down in here because you're compromising that thickness. So you got 2 shots, 1 from each side. So I literally dropped it down. Center of this was 0. So it's down to, you can see, 10 thou. Clears all the way through. And then I'm going to flip and go for it. I don't do a lot of tabbing. I was certainly pleasantly surprised how thin I could get that tab. And it still stayed relatively stable. Now I will say, you know, there's a little chatter down in there for sure, but all in all, it really was not bad. So the way I programmed it, just to show you, in this case, I did create, let's see if I have it turned on, probably on another layer, but I created 2 wire frames. Yeah, so see that line right there I drew, and then this line is how I gated my tricoidal. I used a traditional dynamic peeling toolpath. So if you look at the toolpath strategies, there's your peel milling, which is your traditional trichoidal path, and that allowed me to spiral through. I didn't have to start so far out. I could have made it start a little bit closer. I was erring to kind of the side of caution per se. But if you look at the toolpath, we're literally just going to come down through and roll through. Now I played around with two different scenarios. In this model, I think I still have the back lift function turned on. I didn't notice a big benefit either way on this tabbing. Generally speaking, I like to use a micro lift. So when you get to your cut parameters, you can tell the machine to, hey, when you're coming back off of it, because you're going to go at a higher feed rate, you can jump up a little bit. I think if I have a lot of large retracts, that's great. In this case, I was so tight, I don't know if I saw a tremendous amount of benefit, but I played with it either way. I think the big trick when you get into tabbing is you don't want to get overly aggressive on your radial engagement. So in this scenario, I did a 10% radial engagement as I spiraled through. And in the end, that then got us to the point where we have, oops, lost my microphone. I had it slightly out of my pocket. So that got us to a point where we had a nice little tab. I can break it off from there, maybe a little bit of cleanup, and we have a finished ornament. So, looking at it, looks like we only got one guess for the cycle time. I know it's tough because if you're not logged in, they don't let you put in the chat. It always drives me crazy. So you're pretty close. He guessed an hour and a half. At the end of the day, this was 2 hours and 9 minutes to machine this entire part. So not too bad, but I'm certainly not going to make you guys wait. In this case, we are on the ball milling on the inside. But with that being said, I want to wish everybody certainly a happy holidays. Have a great New Year's. And I look forward to seeing everybody when we get into 2026. So hopefully you're enjoying the events. Like and subscribe, and check out more to come. Thanks, everybody. Have a great day.